So I really hope that at the end of this forum session, we will have some real breakthroughs. And it's all about what is stopping the laboratory to really with innovating technology. And I know there are two different sections here, and I think that was already mentioned in previous presentations as well. In quality control, we typically don't want to change because it's all regulated and every change is a new SOP, which we don't want. And in R&D, it's more the opposite, more or less, because we want to have the latest technology to do more research. So that's a fundamental change here in mindset, to be honest. But nevertheless, let's focus on the innovating with technology. How many people in this audience are still using paper as the main way of documenting content in the laboratory? Wow, that's significantly better than in a couple of years. So we are doing the right things. That's good. If you would not have said that, I would say that my next question was how many people are still using cassette machines? Here we go. Okay, I'd like to ask the panel to introduce themselves, and then we start with the session.
So my name is Janet Cheatham, and I'm from Amgen, and I work in the Process Development Organization. In my career, looking at Peter's data lifecycle, I've touched many parts of the data lifecycle, from basic R&D, now process development, looking into operations, manufacturing, and QC. I have two roles. One is I actually lead the digital transformation efforts for process development labs at Amgen, and you'll hear more about that tomorrow. And then secondly, I'm the chair emeritus, which makes me feel very old, of the Allotrope Foundation, which is focused on data standards for our industry.
Thank you.
Hello, my name is Roman Affentranger. I work at Roche Pharma Research and Early Development Informatics, specifically in a group called Discovery Workflows. So we are really focused on the early phases of research. My group specifically is focusing on small molecule discovery workflows. So this means my main customer area are chemists, process chemists, areas like high throughput screening, compound logistics, and this type of areas. And just about now, we are starting with a big strategic initiative on digitalization, on transformation of our lab into a more digital era and automation. And we're trying to wrap our heads around about how should we do that? How should we build sort of solid architecture that we can then build this type of new processes on top on? So we are really getting started on that, and I'm quite excited to hear from the colleagues about, you know, where have they been successful and where have they struggled? What are the problems they're facing, and where do things go well?
Hello, my name is Adrian von Mühlen. I'm with BSF Coatings. I'm in the application and product development team. It's a strategic team. My role is to head the digital transformation of our global R&D and customization labs. That means I look into the tool landscape that we currently have, basically on SAP based, and we like to connect this data that we have with the feedback from the lines to get an enhanced lab infrastructure, saying that we could tap into new knowledge thanks to the connection of the data. All visionary, but still under progress, and I'm in the road mapping process. And as just Roman said, I'm also curious to hear about your knowledge on the same road and hurdles and how you mitigated them.
Hello, my name is Mark Gonzalez. I work for a vendor called Labware, who's involved in LIMS and ELN and similar types of technologies. In my lifetime, I've worked on a number of projects to try to help the organization go from sort of more traditional ways of working into more modern ways of working. And I've seen examples of roadblocks and issues, whether they're cultural or political or business-wise. So I'm also quite interested in getting sort of a refreshed view on that and seeing what everyone thinks about it.
Okay, thank you very much. So in the next half an hour, more or less, 35 minutes, we will highlight 3 different topics on this here. One is the situation, where are we now? The second topic is really, I want to focus on the potential solutions. And then the last bit, probably is the most exciting one, is the bright future. So I'd like to ask one of the panel people here is, what is the current situation and what are we really facing in the laboratory? What are the issues?
Well, I come back to the example we discussed yesterday over a beer at the lobby. We have lots of instruments with different interfaces. Famous is the RS-232, and sometimes some of the current computer systems don't interface anymore with this, and then we really start to struggle. We have then this converter, this doesn't work, this does kind of interfere on the data stream. We have then results we cannot interpret anymore. That makes it difficult. So there is also just a question into the round, what kind of standards can we go for that we get rid of this zoo of different interfaces and communication channels?
I think one of the other things that we're facing in the laboratories is I think our scientists are under more and more pressure to get data faster, to drive decisions faster, to drive faster product development. And in addition to that, they step outside of the laboratories, when they leave at the end of the day, and they have a digitally connected world where they can find access and use data very easily. So I see frustration building in the laboratories, because I think at the end of the day, people would like the connectivity and the access to the data. They're just really struggling with how to get that in a meaningful way, in a time frame that's relevant to them, and at a cost that's realistic for the business.
So if you have this frustration thing, what are the top 3 experiences you have from the laboratory, from the people in the laboratory? What are the top 3 challenges or frustrations? To write it down over and over again, or not able to find, or what is the frustration?
One would be the time to find data. The second is probably the repetitive request from management to reformulate, retabulate, and represent data in PowerPoint presentations to have a discussion around data. And then the third would be just the challenges of the multiple interfaces that they have to work with in order to just get their job done.
So I think to add on what we've heard so far, what I seem to observe with our scientists, and again this is quite specific maybe for research, is maybe starting about 8 years ago or 10, we focused a lot on making things electronic. And this was advertised as it's going to make you guys more efficient. You can work more effectively, faster, you will save time. And we introduced things like ELNs and other type of workflow tools to capture the data in electronic formats. And this went on for up until about 5 years ago. Then we kind of switched over to say, okay, efficiency, that's fine, we've done that. Let's focus on making research itself, the innovation process, more effective. Let's focus on integrating data. Let's help people get access to data. Analyze them, it should be readily available wherever you are. And it was more on this more scientific aspect. And lab efficiency, you couldn't get any budget for that anymore, hardly. And I think what happened then is the scientists realized ever since in those last 5 years, the world has not changed in their workflow tools, in the way they capture data. It has stayed the way it has been about 5 years ago. The ELNs are still the ELNs, and they still work exactly the same way they have 5 years ago. And the same with many other tools. And I think now they start to demand something more. And also a lot of the promises that have been made at the time about efficiency with going electronic, they probably didn't really hold true. The labs didn't get as much faster as we promised them or vendors promised them. So now they're going back to demanding that because, yes, we also see them under pressure.
So what I always hear in my consultancy practice is that people say it's slow or it's faster or we expected more. It always reminds me when we get a new PC, the first day it's super fast. And then after, well, it depends on if you run Windows or Mac, it goes slower. And at the end, the system is still as fast. But the point is you do more with it. And if you get then again a new computer, it's again faster. So everything is relative in that respect. So what I see often a lot is, did we have metrics to really prove later on that if something is slowing down, what was it before you went electronic? Or before you went to ELN?
But I think that's exactly the point, and it's the same with computers. So if even websites get more complex, you download a lot more data, your software is getting more complex. So the computer that's been fast 5 years ago is now slow. And that's when you buy a new one. And that's exactly what's happening now in the labs. The type of tools that we introduced 5 years ago, they were fine at the time. but they are no longer because the pressure has increased, the demands have increased, the complexity has increased. So now the tools that were fit for purpose 5 years ago, they need to be replaced. Something new needs to come. And it's not as easy as just going through a catalog and purchasing your new laptop. It's more difficult, and that's, I think, we are right now at this moment.
Mark?
And then, of course, there's also the economic realities. For example, sometimes instrumentation is replaced because the vendor is choosing to obsolete that particular model. They might make it difficult to get parts for it or consumables, etc., because their interest, of course, is to sell the next model coming along. And these are factors that are not technical in nature. These are just the reality of the economic world that we live in. So there are other forces that are at play as well. Along the subject of standards, for example, allotrop, standards are very helpful, but also standards can have a negative effect on things like innovation. They can hold back companies from doing the next great thing because they have to or wish to abide by certain standards. We see this especially with hardware. You know, nobody's going to buy a computer nowadays that supports USB 2 because they know that USB 3 is the next great thing, or whatever the next thing that Apple or Microsoft or whomever come out with. So there's also this fear that people have of being left behind, where they embrace emerging technologies perhaps at too fast a pace.
So should we not include in our laboratory processes a much more proactive retirement and retention policies for equipment in that respect? It's amazing to see how many people want to connect a balance to a LIMS or ELN, and the balance is 25 years old. It's cheaper to buy a new one which has all the connectivities than to maintain the old. And then the message is very often, we don't have money for the new. But believe me, there's much more hidden cost, significantly more hidden cost with something old. Are you facing the same thing?
So I think, you know, it's interesting, and I actually just have to digress. I have to respond to the, you would expect nothing more of me than this with respect to standards being constraints around innovation. It can be constraints. I think one of the things that's interesting about actually the conversation with scientists is understanding the fact that actually standards, especially around contextualization of experiments, can actually unlock innovation and can free up time because you can find, retrieve, and aggregate your data faster. And I think going to then the topic of sort of equipment and the life cycle of equipment, making changes in the laboratories, the reality is that laboratories have economics, companies have economics. And I think when you look at equipment, whether it's hardware or when you look at software, incremental is expensive and there's no longer an appetite for incrementals. So you have a twofold increase in sensitivity. For the majority of experiments, that's not going to make a difference. So you're not going to see that instrumentation life cycled very quickly. On the other hand, if it's a 10 to 100-fold increase in sensitivity, your experiments are challenged by sensitivity. Then you're seeing those investments. So I think the dynamics is changing, and I think the labs are trying to respond to an environment where they can upgrade and replace their equipment much faster. Mm-hmm. But if it comes with a new IT project, it comes with new sets of integration of software to that hardware, then you're basically adding to the technical debt of that life cycle. And I think that's a legitimate challenge.
Okay. So sometimes what you're saying here is that yes, we want to change, but it is not always, we don't need to change from a scientific perspective, but sometimes you need to change and upgrade the infrastructure to make that happen. And we are now living in a world, unfortunately, where those technology infrastructures is changing from day to day, more or less. It's amazing to see what you've done 3 years ago versus what you do today with the same type of infrastructure on technology, on the technology stack. Okay, let's go to the second. How can we resolve those issues? What do we need to do? What is the process where we can say how to facilitate the change? From the laboratory perspective, from the supplier perspective, from IT, from budget, whatever. Anybody who wants to comment on that?
I think that the first element, probably the most easy one, it's also, it's a bit a weak one. But I think we just need to accept that sometimes we need to be opportunistic. And especially because we have a long legacy of the instruments that have been around and they cost a lot of money, and you're not just replacing all of them at once to build your lab of the future. But sometimes a department may move to a new building, or something like that happens, a big change. I think it's those opportunities that we need to grab then and be planning them early enough to use these opportunities to then really make those type of changes and build those new labs. And this is what we see very often is the big steps in the labs are happening exactly then, when either they move to a new building or they have these big changes coming up that give them the excuse to just eradicate whatever they have and build something brand new. And it's a bit sad, but I think that's just the way it is. And we need to accept that this opportunism, is that a word? Yeah. That this is fine, and that's probably just the one thing we can do. There may be others, but that's, in my opinion, the most straightforward one. And I want to continue.
I think comments were made this morning in the open presentations that it's important for organizations to see their laboratory operations as business components, and not just as some kind of backdoor entity that just does stuff for us from time to time. The more that they're recognized and respected as a critical part of the organization, the more likely they will be to be encouraged to be up to date and use the latest technologies and embrace all these things. Because my experience is that laboratories often suffer from change anxiety. There's a lot of fear in the minds of the people within the laboratory about this emerging change. Everything we did before was fine, so why do we need to change what we're doing? We're doing what we're supposed to. And change is often pushed into the organization by external forces. For example, money. When a company chooses to modernize its production facility, they're doing it often because there's commercial pressures to do so. And the same thing probably needs to occur, in this case, for laboratory operations as an entity.
Well, there was an interesting case. A couple of months ago, we had a big issue in Europe, right, about eggs. Right? There was something huge, big time on eggs. And then the laboratory was extremely important for the whole world. Because only the laboratory could identify if those eggs were good or not good, or at least something to do. So then the laboratory then there's a link between what I call the general audience, and now they understand that. Management sees that, because hey, they don't want to be on the front from the newspaper, and then the lab is important. So then budget was no issue at all in those days. So is that another thing, that we are not making our activities, our processes in the organization more valuable to the organization? We are more with a scientific approach rather than a business approach?
That is currently an approach we as BSF Coatings are starting. We set up an initiative to do a smart lab or lean lab, and there we just did what Roman said. We started a completely new building. We made from scratch new processes. We started with new software, with new limbs. We connected the equipment, but then we run into a problem. Just what you cited. We didn't communicate well and prepare well the teams, and so they are kind of struggling now, moving into that new system. That now I'm serving a machine because my tasks are given away to an automate, to a robot. What is then the purpose of me? What is my role in the future? There were lots of unspoken sorrows and kind of reluctance towards the system. And now we are really struggling, after having implemented it, after having moved into that building, that we can fill it with life. And I would say where we really messed up is in the change. And that's what the next time we have to considerably take care of that right away from the planning phase. Because it doesn't help you to have the best equipment, the newest piece of software all together connected, if the people do not want to use it.
Or they feel threatened by it.
Yeah.
Anybody from the audience who has a question or has a remark on this? What are your proposals? Or are you not facing this issue? I can't hardly believe this, but maybe it is. If so, we should change the audience here. Nobody? So nobody says, hey, I have an idea how to really make this change, how to make this happen? Again, this is your meeting and not mine.
So I'm Michael Spalding with SGS, and we are a CRO, and SGS's life science division has kind of grown by acquisition. So we have a lot of different labs that have a lot of different equipment. And then of course there's a huge, we're GXP. We do GXP testing, so the focus has all been recently on data integrity. But the biggest challenge that we face in our labs is it's the variety of equipment. So, first of all, you talk about getting the business to modernize its equipment. Well, the labs are under so much budgetary pressure that when they bought balances, we're trying to get all the balances connected. We're very far behind. And we find that they didn't even invest in the Ethernet port because it was an extra, $300. So we have all this extra work. But I think the equipment vendors could really help this by, and I have a lot of ideas about that. But I think, I really like the approach that Allotrope Foundation is taking, because what's really making this project so complex for us to automate our labs, again, it's the variety of equipment, and then each equipment has data in a different format. There's a different learning curve, for the analysts. So a lot of challenges around just the complexity and the variety of equipment. So our labs that standardized on certain equipment are much further along, where we have part of it's because of our wide range of service offerings. So.
If I could just make a comment towards that. It's important to remember that the consumer is king. You're in charge. It surprises me that organizations buy any instrumentation and don't write into the contract that that instrument should be able to be connected to, for example, a LIMS or an ELN or whatever. That would just be one extra sentence in the contract. Probably would not increase the price of the instrument in any way, shape, or form, because the vendor just wants to sell the instrument. But if you forget to put that in, and you ask them for the cable 1 month later, it's going to cost you $300, euros, whatever you want, because that's business. The cable actually only costs about $10. But that's just what happens. So from this moment onwards, don't buy anything without demanding it, and it will happen.
Yeah, and one of the challenges is we have scientists who are doing the buying, and so we are trying to change that process to get, the IT and the business involved in that decision. But the other thing I fault the equipment vendors on is, they're selling equipment. That's why we buy it, for the scientific reasons. It also happens to have this data station attached to it. They sell you a piece of equipment that lasts 15 years, but they don't give you a 15-year life cycle for the IT equipment. So when XP expired, we have all these, $500,000 mass spec instruments that now our corporate IT security department won't let us put them on the network, and we're really stuck. So so to me, along with insisting on that interface and in the contract, we need to start holding the vendors to, providing a life cycle for the IT portion of their equipment that is in sync with the lifetime of the equipment.
So I just wanted to make a comment, Peter. So I think those are really good points, and I think it's an example of, so how are we going to influence and change the future? So if we just keep doing what we're doing, we're not going to be effective in doing that. So there's an opportunity for partnership and collaboration here. One is, rarely in the lab now does equipment provide value, right? Lab's value is it provides data, right? And a set of capabilities, right, to generate data. Hardware and software are now inextricably linked in order to be able to generate that data. So the idea of the IT life cycle that goes with your hardware life cycle, I think is great. The second thing is, don't sell us equipment that isn't connected, because when you look at the sort of purchasing departments that go through when there are economical pressures and see what you can cut out, what they don't look is the long-term cost of that. So it may cost you 5 times as much ultimately to integrate that equipment than to have paid the $300 for the Ethernet port.
But that's a hidden cost.
So I think it's an opportunity for us to partner to say, what is the kind of equipment package that makes sense to sell, such that if we do a good job of educating our management as to why there's value in having a package and an instrument that has life cycle over software and comes plug and play, and then also you give us the benefit of providing that as an entity versus base price plus this, plus this, plus this. So it's an opportunity for us to think about.
So I'd like to highlight here as well your statement about suppliers being able to really connect for the future. But some of the technologies were not available when those instruments were produced. The whole internet thing, the Internet of Things, is just only 2-3 years old in that respect, that mindset. So a lot of the technology, look to websites where you have to go from PHP to HTML and to all of, that's only new. And so a lot of those equipment While in the future, the past mindset, and I think that's where the change should be, was based upon the scientific challenge only, right? How can I do the science, the instrument make better? And they didn't think about the other stuff. Now that's becoming an issue. So there's also a legacy on that. Having said that, I also have experience, I'd like to get your feedback on this, is if I do a lot of research or going through laboratories and see how people work, what still amazes me, and I like to get feedback from audience, from suppliers, everybody, is what still amazes me that 80% or 75, 80% of everything we start in the lab is starting with waiting. And to get the balance number into any system, or in LIMS, ELN, tablet, whatever it is still a nightmare. You need to get programs. Why is it, and this is a story I made a couple of years ago when I started this on the paperless lab, and is why is it that if I buy any machine, any phone, I can use any car more or less, and I can connect through Bluetooth, which is nothing else than RS-232 on a wireless protocol. So no change. And why can I do that without going to any supplier? And why can I not get 2.5 milligrams from the balance to that? And I once have thought about it would be a great business model, and maybe this is an opportunity for somebody, stand up here, to create a business making drivers for iPad and whatever on all the balances and all the software packages available for 2-3 euros. You will sell millions. And I think that's for me what I see a lot of frustration, that I'm writing down the same thing over and over again as part of my process. So I like to be challenged. That's what but that is what I see a lot. And there's a lot of frustration in laboratories on this to rewrite again, over and over again. I even have seen companies making pictures, photograph of the display using OCR software to find out what it was as being digital. But a dot and a comma in US and Europe means something else. So, I mean, so think about that for a sec. So there's a lot of this kind of, I call it basics. And the technology is all there. All balances, Sartorius, Medlar, they have RS-232. They just put a connector on and they're wireless. They're Bluetooth. Very easy. So it's really the ability to connect that to the application where I think the challenge is. And keep it simple. On the allotrope thing, I've been for a year more or less one of the initial allotrope advocate guys in Europe. I mean, data standards is important, but even more important is the ontologies behind that. Because that makes you find the data at the end. And that's something very misunderstood, that people think it's only the data standard. That's only part of the problem. And that's another issue. If we can fix that also, I believe, will be probably something for the bright future. Janet, do you want to?
I'd like to add a point or even a thought or expand that thought a little bit, because the last 5 or 10 minutes we discussed a lot about instruments, kind of a new wave of replacing instruments, getting more connected instruments, better instruments, more sensitive instruments. Again, a new wave of getting lab processes more efficient. But I think that's just half of the story. I think the real challenge, and I think there we can be more active and not just be opportunistic, is the actual change that I think is happening right now is, even also in the title of this discussion, it's about where does innovation happen and can the labs innovate with technology? I think up until now, the scientists have innovated mainly with their brains. And they see technology growing and maturing to enter into that space and to enter into this innovation space. And this is, on one hand, an opportunity, and people are excited about that, but it's also a threat. And because it's competition. It's not just a scientist and his brain that is doing the innovation, but now they see the potential and also the risk that technology could actually step into that realm. And this is something we could manage and we could help. We could facilitate this change management process with our scientists to help them still keep their role, keep their understanding of their relevance in the labs, and embrace the fact that technology can even step into this innovation area. And I think this is one of the things where we can really and should be active, but I do find it quite difficult. But it's definitely something I think we should do, because it's really not just a new wave of getting labs more efficient or better or more connected instruments. It's a more fundamental change that I think is happening or is about to be happening right now.
So it's a mindset thing.
Yes, yeah. I mean, I had a discussion just before, and somehow it reminds me of a discussion I had in fall with some chemists. And I challenged them to ask, what is it you're doing? Is it an art or is it data-driven science? And then they said, of course, it's data-driven science. But then as we got to the heart of it and we started to discuss about things like artificial intelligence and stepping in, it turns out that they say, no, actually, it's really more of an art. And this is really this confrontation that is happening right now with the scientists. That for a long time they could get away claiming they're working in a data-driven way, even though at their heart they still consider themselves artists. Now they can no longer. They really need to face that, and they need to pick a side. It's either or, it cannot be both. And this is happening right now.
So Mark Goulding from Merck, and working in materials R&D. And the mindset thing is very interesting because we observe in our R&D center the full spectrum of digitalization in the lab, ranging from projects which have been running for a couple of years with a new team, younger generation, and much more digitalized than projects which have been running for 10 to 15 years, older scientists where they're more established with their traditional methods. And it causes a real tension because on the one hand, the older generation has a proven track record with its paper-based lab notebooks. They know what they're doing and they're working very much to their intuition. And the newer groups, which are using data analytics, connected instruments, electronic lab notebook and stuff, are very, very much more kind of on that side of the fence. And so we're trying to pull them through, but it causes real problems because the biggest single challenge to this is, well, how am you going to replace my paper lab book in the lab? How am I going to get the 10 years of data which is in my paper lab book into some format where I can find it as easily as when I was using the paper lab book?
And one of the driving forces, especially within R&D, for wanting to embrace these kinds of technologies is the notion of collaboration across individuals, not just to get back your own data, but to be able to access and see what somebody else has been working on.
Yes.
And historically, the mindset was, this is my data, I'm working on it. I don't necessarily want to share it earlier than I need to, because it might be imperfect. But the good news is that that mindset is changing. We live in an age now of openness. We publish photographs of everything we eat. We tell everyone our status and what's going on. The age of keeping things to yourself is kind of disappearing. So one would hope that this is the light at the end of that tunnel, that individuals will see the benefit of, shall we say, oversharing as opposed to undersharing.
Okay.
I think you also mentioned an interesting point about the generations, because I think not until too long ago, the generations in our employees or in the people kind of were aligned with technology generations. And now it's within one generation of a human being's life, we have many, many generations of technology. So the diversity in technology is so much larger and compared to people. And I think this is yet another challenge that we see exactly the same too.
So I think, it's also interesting, and I agree 100% about the shift from it's my data, knowledge is power, it's how I succeed in an organization, to we're in a collaborative endeavor. You see that with companies, collaborating with each other around assets. You see companies and academics working very closely together in a way that you didn't a decade ago. But I think it's also recognizing and being able to share the value proposition for the individual, because we can talk about collaboration, we can talk about how it's good for the company, it's good for society, but at the end of the day, the individual wants to know about me. And there is a general demographic statement, I think, about generations, but there are outliers. And so I think it's investing in the outliers and actually pairing people who want to transition with the technology, but need the time to learn. Oftentimes, we don't give people the time to learn the technologies. The technologies are not intuitive. There's much more that could be done. The person who's using a paper lab notebook, it's very easy to write down stream of conscience. You don't have to capture or contextualize with standard metadata. When you go to an electronic system, if you put a constraint on the time it takes to record the experiment and capture the result, you're putting a barrier in terms of that individual being efficient in the lab. And yet, when you talk about the applications we use on our phones, where it's intuitive to be able to share the photograph, and intrinsically the photograph has the GPS coordinates of where you are, and it tells the person you're communicating, those types of innovation around interfaces can and should move to the laboratories, and I think they'll really ease the change curve.
And I would just add on here, from the experience we run in BSF Codings, our ELN system we have is, from point of view of the user interface, not top. And we always have a struggle to serve that to saying the people who know to use it, because it's made in the mindset of paper-based workbooks. So the experienced scientists, they know very well where to go, where to document, and to do everything. The younger generation exactly suffers that issue. They look at it and say, oh gosh, what's that? Where does this come from? And it's from 1997. It's kind of SAP style, COBOL, very awkward. And that's where we have to change and also to profit from innovation, that we may stick in the data structure which is behind, because we want to track also on the legacy data. That's important. However, we can also fine-tune what is the interface to the users. And actually, for me, the lab people are the most precious resource, because they generate the knowledge, which is then documented in data. And I also like to profit from this generation who knows to carry out research, because they are trained, they know exactly, if I want to do a patent application, I have to do this, that. A younger fellow who comes from university might be more agile on software tools, on apps, but he has not yet that mindset, what do I do, or what do I need to get to the point that I can apply for a patent? And actually, as a company, we need this, because that's how we run our business and how we protect ourselves. So there we have to really go for this innovation. And honestly, in our company, we have there a bit the problem just to change the current system, because every time I come up with, oh, we have to change the GUI, oh, Adrian, never ever. No, don't touch. It costs us several $100,000, and it takes years. It will be the end of your career. Don't touch. And I'm just also looking and watching out for people helping me, startups, just to interface between the current ELN interface and make it a bit more user-friendly. I would also like to go that the ELN already, because we are with the LDAP or whatever kind of system you use to log in into a machine, already knows it's that kind of lab technician. He has that role. So he has to see this mask and not the entire 2,000 fields and 20 masks that you have to go through. No, there we can go a simpler way.
Okay, thank you. I like to thank the panel, because we are running out of time now. It's 12 o'clock. A couple of closing words from my perspective. Sharing is great, and ELN and LIMS systems are great in doing that, but we also should assure that we get a new dimension in this, which is the legal department. When do you want to share? There's a significant difference in sharing something on Facebook from yourself and something to share some information from the company, because the information you do and you create in the laboratory is not from yourself, but from the laboratory. So there are different, I'm familiar with a couple of cases where even certain analysts were not able to talk about a certain project because of non-confidential NDAs and all that kind of stuff. So that's another thing we should, and that's coming up, the GDPR, which is something which is hanging as a cloud above us, is something you also should be aware of as a new challenge to be aware of. And I think ELN and LIMS systems are great instruments to really manage those kind of security. Okay, I'd like to, again, thank you for the panel.